So here is another question on projectile motion with horizontal projection. So it is given that a body is projected horizontally from the top of a hill with a velocity of 9.8 meter per second. What time elapses before which the horizontal and vertical components of the velocity they become equal? Okay, so let us try to understand this. So first let us try to draw the whole situation. So we have a hill. Okay, so let's say a person is standing here and he threw an object, let's say a stone or whatever it is. He threw it with a horizontal velocity of 9.8 meter per second. Okay, this. So if you remember, we discussed that when we discuss horizontal projection, when there is no component along the vertical direction, no vertical velocity component, then we write it as ux, and here as no vertical velocity component is there, so it is simply 0 meter per second, the initial vertical velocity component. Okay, initial. So now this object, it will have this kind of a trajectory. Okay, where finally it will hit the ground. Now, during the course of the motion of this object at different points, okay, let's say this point, this point, this point, the horizontal component will always be constant. Okay, this horizontal component, it will always stay the same. Why? Because there is no acceleration or retardation component along the horizontal direction. So there is nothing to oppose the horizontal motion or nothing to support the motion. So there will be no increase in the horizontal velocity component because acceleration along the x-axis, the acceleration component along the horizontal direction, that is 0. Okay, that's why there will be no change in the horizontal velocity component. It will remain constant, uniform throughout the motion until it hits the ground. But we have gravity acting downwards, acceleration due to gravity acting downwards. The stone is moving downwards. Okay, it is not moving in a straight downward motion but like this. Okay, so it has both horizontal and vertical components, horizontal and vertical displacement. So for the vertical component of the motion of the object or the stone, whatever it is, this acceleration along the y-axis, that is equal to g plus g. Why? Because it is the acceleration due to gravity is also acting downwards, and the motion of the stone along the vertical direction is also downwards. Okay, it is also downwards. So during the course of the motion, the y component will slowly keep on increasing as time passes. It will slowly keep on increasing, and it will be maximum just the time instant before it strikes the ground. It will be maximum, but the horizontal component will always be constant. So we have to find the time instant or the position where both the ux component is equal to the Vx component, the Vy component. these are all v. Okay, this is not u because that is initial velocity, these are intermediate velocity, so we'll use this sign v. Okay, v. So this is v, this is v, and this is also v. So as this is constant, this intermediate velocity component will always be the same, ux, which is equal to 9.8 meter per second. So we have to find this particular time where Vx will be equal to Vy. Okay, any time instant, because the y component will slowly keep on increasing. Initially it is 0, but it will keep on increasing as per this equation. Vy is equal to uy plus gt. Actually the equation is Vy is equal to uy plus ayt, as ay is equal to g, so Vy is equal to uy plus ayt. Now uy is 0, so it will become 0. Vy is equal to gt, which is equal to how much? 9.8 t. This is the expression of the intermediate velocity of the vertical component, the y component. We want the time instant because where both horizontal and vertical velocities become equal. Horizontal velocity is always constant, u, that is equal to 9.8 meter per second. So let's say 9.8 t is equal to 9.8 meter per second. So that implies t is equal to 1. So after 1 second from the time instant the object or the body is thrown, both the horizontal and vertical velocity components will become equal. Okay, t is equal to 1 second. Simply what we have done, we have used the basic concept of projectile motion. Horizontal component of the velocity will always stay the same because there is no acceleration in the horizontal direction. The vertical component will keep on increasing slowly as per this equation. We have to find a time instant t where both the horizontal and vertical they become equal. So horizontal is always the same, 9.8, so we equated it with this Vy is equal to 9.8 t, where t is the time instant or the time interval or the particular time instant after which the stone is thrown, where both of them become equal. So this is equal to this and t is equal to 1 second. This. So this is the answer. After 1 second has elapsed, both the horizontal and vertical components of the velocity they become equal. T equals to 1 second. Okay? So here is another question on projectile motion. So here it is given that two tall buildings face each other and are at a distance of 180 meter from each other. With what velocity must a ball be thrown horizontally from a window which is 55 meters above the ground in the first building so that it enters another window 10.9 meter above the ground in the second building? Okay, so this is the situation. So now here let us first try to understand the whole situation by drawing the diagram. Okay, so here we have the height of the building is not mentioned. We have, let's say, one building, okay, like this. This is the ground. We have, let's say, a window here. Okay, a ball is thrown from here. It is mentioned that this window is 55 meters above the ground. in the first building. And we have another building. Again, the height of the building is not mentioned. The thing which is mentioned is that there is another window in the second building which is 10.9 meters above the ground. So we want to throw a ball from the first building with a horizontal velocity, and we want to make sure that it exactly enters the second building. So we want to determine with what horizontal velocity the ball must be thrown, and the separation distance between the two buildings, that is equal to 180 meters. Okay, so here the net vertical displacement, in case the ball exactly reaches this second window, the net vertical displacement undergone by the ball is simply the height of the first window minus the height of the second window above the ground. That is the net vertical displacement. Okay, that is the net vertical displacement, that is 55 minus 10.9, that is equal to how much? It's 44.1 meter. 44.1 meter. This is the net vertical displacement. So here some parameters. Again, we have solved so many questions, so you are familiar with that. There is no vertical component of velocity, so uy is 0 meter per second, initial vertical velocity. Okay, initial vertical velocity uy. Then there is no acceleration component along the x-axis, so that is also 0. Gravity is acting downwards, so it is supporting the downward motion of the ball because it is moving from here to here, to one window to another which is at a lower height, so it is supporting that. So ay is equal to plus g, nothing is mentioned, so 9.8 meter per second square. Okay, and here the net horizontal displacement Sx is the separation gap between the two buildings or the two windows, that is equal to 180 meters. So this much parameters assignment, that is done. Now what we have to do is we have to put the equations of motion, the component form. So first is Sy is equal to uyt plus 1/2 ay t square. Initial vertical velocity is 0, so this whole thing will become 0. So that means Sy, which is the difference between the window heights, 44.1 is equal to 1/2 into ay, that is equal to acceleration due to gravity, into 9.8 into t square. That implies t is equal to 2 into 44.1 by 9.8 root over. So it is simply the time of flight equation, 2 into height difference by g. So it is coming around t is equal to the time of flight is equal to 3 seconds. It is coming. Okay, t square is equal to 9 and t is equal to 3 seconds. Okay, this is done. Now here the horizontal distance covered by the ball, that is equal to, we know, the product of the horizontal initial velocity, which is constant throughout the projectile motion, multiplied with the time of flight. This formula we know. So here Sx is given, that is the net horizontal distance covered or displacement covered, which is equal to the separation gap between the two buildings, 180 meter. The time of flight we calculated 3 seconds. We want to know the initial horizontal velocity. So simply ux is equal to sx by tf, which is equal to 180 meters by 3 seconds, that is equal to 60 meters per second. So this should be the initial horizontal velocity, so that this ball, it will reach from this first window to the second window with the respective height above the ground. Okay, so this is the initial horizontal velocity which is required. Ux is equal to 60 meters per second. Okay, so this is the answer. Okay, so again, simple application of equations of motion applied in their respective component forms x and y. The only thing is to assign the values correctly, the initial velocity, acceleration and net horizontal and vertical displacement. That. Okay.